In this video, I will be discussing the 2005 AMC 10A question number 24. For each positive integer n is greater than 1, let p of n denote the greatest prime factor of n. For how many positive integers n is it true that both p of n equals to square root of n and p of n plus 48 equals to square root of n plus 48? Right off the bat, understanding this problem, let's go over it. P of n will be the greatest prime factor of n. So if you write out the prime factorization of n, well, P of n will equal to the greatest prime factor. For example, let's say that n equals to 6. And this will equal to 2 times 3. So P of n will equal to 3 because it's the greatest prime factor and it's larger than 2. And now that we know what P of n means, let's go for the problem. Well, P of n equals to square root of n. So obviously n must be a perfect square because we know that P of n is an integer. So n has to be an integer perfect square. Same goes for n plus 48 because n plus 48 has to be an integer. So because P of n plus 48 has to be an integer, so n plus 48 is an integer. Now, so P of n equals to square root of n. So we can get that n equals to p1 squared. We let n equals to p1 squared. And now where p1 is prime. Because since P of n is a prime factor, so we basically let P of n of this prime factor be P1. Now, Pn plus 48 equals to square root of n plus 48. So we can get n plus 48 is a perfect square. And now you still might be wondering, there's so many perfect squares after. There's like infinite number of perfect squares. Do you have to try all of them? Well, no, because we want n and n plus 48 to be simultaneously perfect squares. So, if you're very fluent in constructing perfect squares and knowing that there are difference, well, you'll see that the difference between consecutive squares after 576 be larger than or equal to 49. So if you have here, if you have n equals to, let n equals to 576, well, the next, well, if you have like m, then m, let m be the next perfect square, but m will equal to 25 squared. That'll be 625. And the difference, d equals to 49, which is greater than 48. So all the perfect squares after 24 squared, you don't have to care about. And now, even better, we know that we only have to consider prime perfect squares because P1 is prime. So difference between perfect squares after 576 is going to be larger or equal to 49. So we only check prime number till 23 because 24 squared is 576 and we only need to check the prime numbers till 23 then. And 24 is not a prime number. So these will be 4, 9, 4 squared, 2 squared equals to 2, equals to 4, 3 squared equals to 9, next one will be 5, 5 squared equals to 25, and then the next one will be 7 squared equals to 49, 11 squared equals to 121, 13 squared equals to 169, 17 squared equals to 289. And then 19 squared equals 361. And 23 squared equals to 529. But this is still a bit too much. I mean, we could do it, but it's going to take some time. And this is AMC 10. So we need to find the best way. But then now that, if these can all be n, but then we need n plus 48 to be a perfect square also. And if you're very, very fluent in perfect squares, you know that perfect squares cannot end in 7. Why 7? Why am I saying 7? Well, because note that adding 48 to perfect square ending is 9, because 8 plus 9 equals 17, and it's ending in 7 will result in number ending in 7. Then you can get that perfect squares do not end in 7. Like, try for yourself. Like 4, 9, 16, 25, 49. Well, you see, you just can't get a 7 out of this, out of the perfect squares. So now you can just remove all the ones that end in 9. 9, 49, 169, 289, 529. So that's a lot of perfect squares cancel out. Now we only have 4, 25, 121, and 361. And now we can use brute force and check. 4 plus 25 equals to 29. Nope. 4 plus, this is going to be, I messed this part up. This is going to be 48 plus 4 equals to 52. And for this one, it's going to be 48 plus 25 equals to 73. 48 plus 121 equals to 169. Now this is a perfect square, equals to 13 squared. So this works. And then 48 plus 361 equals to 409. So you'll see that the only 121 works. So only one positive integer n works. So then we get that the answer to this problem will be B, 1. Key part of this problem is noticing that, well, the difference between perfect squares after 576 will be greater or equal to 49. So you can just remove all of those, and you only need to check the prime numbers, because the greatest prime factor means that it's a prime number. So you only need to check the prime number, the perfect square of prime numbers up to 23. And then you can also get that adding 48 to a number ending with 9 will result in a number ending with 7. And a perfect square cannot end in 7. So you can cross all the perfect squares that end in 9. And using a bit of brute force, you can get that 121 plus 48 equals to 169. And this is the only one that will work, because 169 equals to 13 squared, and 13 is a prime. So that's how we got the answer B. Thank you for watching.